It's time for math. So we're going to continue Algebra 1 with our next lesson in Chapter 8. So this lesson is called Chapter 8 Introduction, Finding Greatest Common Factors and Least Common Multiples, also called GCF and LCMs. So this is an introduction to the factoring and GCF LCMs, but it is in the middle of Chapter 8. So a little bit of it is review, and a little bit is just one more step to taking your review, what you should already know, and working into polynomials. Okay, so I want to talk about factoring for a minute. You've done factoring before, I assume, but let's talk about it. If we want to factor a plain number like 20, you might have done this, you should have done this, where you find the factor pairs. 1 times 20, 2 times 10, next one will be 4 times 5. Okay, there are the factor pairs. Then, so if we want to list all the factors, here they are. No doubles, right? We don't want to put down the doubles. Those are all factors. We want to have prime factors. So prime in math works a little bit like atoms in science, right? You can't break an atom down and still have distinct matter. The atoms are the smallest building blocks of physical matter. So a prime factor is the smallest building blocks of a number, okay? Of a whole number or a real number. So if I want to do the prime factors of 20, I'll have to break these down until I can't break them down anymore. So let me do prime factors over here. So I don't want to find pairs. I want to just start splitting it. So I can start with, this one won't change, right? I'm going to start with 2 times 10. Okay. I know that 20 can factor into 2 times 10. Now, that's nice. 2 right here, that's a prime number. So we are finished with the 2. 10 is not a prime number. If you need a list, you can find a list of prime numbers. 2, 3, 5, 7, 9, 11, 13, 17, 19, etc. They are numbers that only divide by 1 and themselves. They don't have other factors. But we already knew this. So we have 2 as a prime, but we need to split this 10. We need to factor the 10. 10 is really 2 times 5. Okay, good. We know 2 is a prime number, and 5 is a prime number. So these pink lines show our prime numbers. So the prime factors for 20 are 2 times 2 times 5. Okay? This works with every number, right? If you start with a prime number, you're finished. But other numbers, you can break them down into prime factors. Let's do one more real quick. This one, we're going to add a little Algebra 2 flair, right? Let's try 24x, that's not an x, 24x squared y to the third. So we did something a little bit like this in a warm-up a week ago. And that asked you to factor this out. So let's start with the 24. What are the factors of 24? I threw the black marker just on the floor. Okay. Factors of 24. Well, I'm going to split it one time into factors. I think it is 2 times 12. If it's an even number, one of the factors is 2. So 2 times 12. Okay, 2, that's a prime number, so that one's finished. 12 is not, so we need to factor that. It's even again, so 2 times 6. All right, 2 is prime. 6 is not. We need to split the 6. Oh, it's another even number, so it's going to be 2 times something, which is 3. Now we know 2 is a prime number, and we know that 3 is a prime number. Okay, we'll count those up later. Well, let's count them up now. We got 2, 2, 2, 3. So we have 2 times 2 times 2 times 3. So that's 24 right there. Okay, that's factoring it. We don't need to put it back together. We leave it as all its little pieces, its atoms. Now we want to factor this x squared. Well, what 2 pieces are in an x squared? Right, it has x squared, so it means it's 2 x's multiplying. So this splits into x times x. Can I divide x's apart? Can I break an x apart? No. So they're primes. They are the prime factors of this monomial. And this y, how many pieces can I split the y into? Well, it's got a cubed, so it's power 3, which means there's 3 y's in there. Y times y times y. And those are single variables that are prime. So those are our pieces from the variable part. They are factors that are going to add to our final answer. So x times x. Oh, something fell over. Y times y times y. Why is that y different? There. It still has a tail, but at least it's a y. So that down there, that long chain, is our answer. Okay, those are the prime factors of the monomial we had up here. So that's the steps we're going to be taking today to find. First, we're going to find the greatest common factors. So the greatest common factors, we will factor, like we did just did on that last board. We will factor 2 different pieces, 2 different monomials, break them into their pieces, and check which pieces match. Okay? So it's just break them apart and match. So let's see what my 2 pieces are, my 2 monomials will be. So this is problem number 1 in your independent practice in the assignment. So if you want to follow along, I put a red star next to it. That means I'm doing it in this video. So if you want to follow along and understand it, here we go. They said, can we find the GCF of 12x and 40x squared? Yeah, that fits. Okay, those are the 2 things we're going to compare. So we're going to break this into factors, and we're going to break this one into factors, and then we'll check if they have any matching pieces. Okay? So let's start with 12x. What can I split 12 into? Well, 12 is 2 times 6. Let me grab my eraser. 2 times 6. Okay. We know that 2 is a prime number. Then we have to split the 6 into factors. 2 times 3. Okay, those are good. Those are both primes. So far we have 2, this one. We have another 2, and a 3. Okay, so that's the 12 finished. Now we need to break this x apart. Can we break a single x into pieces? No. So he will just come down by himself. He's already a prime factor. The x is already finished. Okay, so our 12x, we have all our pieces. Okay, Now let's check our 40x squared. Okay, let's break it into pieces. 40, we need to factor that. 2 times 20. Okay, 20 is even again, so break 20 into 2 times 10. Okay, 10 is even. Break it into 2 times 3. So in a lot of these, it's very common to have lots of 2s and some 3s. Okay? These are the most common factors. You can get other prime numbers, but a lot of the time, it's 2 and 3. Okay, so 2 prime, 2 is prime, 2 is prime, 3 is prime. So we have, dropping stuff. We have a 2 times a 2 times a 2 times a 3. This one, this one, this one, and this 3. Okay. Now we need to split up the x squared. All right. 1x can't split, but x squared, we have to split this. The squared means it's x times x. Now we have 2 prime x's, 2 factored x's. So they will come down to join our answer. All right, box it up. Okay. Now we have to just compare the 2 answers. So in blue, I don't need that. All right. In blue, I'm going to circle if the number is here and here. Okay. 2, there's a 2 here and a 2 here. All right, that's one common. 2. Then there's a 2 here and a 2 here. Okay. So we got another 2 in our answer. Okay, now we have a 3, and this side has a 3. Okay, so those are common. Then we have an x here and an x here. Okay. Now this side has another 2 and another x, but they don't have any partners over here. They have to match on both sides, or we can't put it in our answer. So this right here, 2 times 2 times 3 times x, is our GCF. This is the answer, but let's put it back together now. 2 times 2 is 4. 4 times 3 is 12. And x. So it turns out that one of our starting numbers was already the GCF this time. That doesn't always happen. But that is our answer. So this is the greatest common factor that these two share. So it's something that they share. Let's try another example, if I can find my eraser. There it is. Okay. We're going to go a little faster, but this is another one from your book, or from your assignment. This is number 3 on the same page. And it says, how about, somebody's yelling for their cat outside, 14n. And the other one we want to check is 42n. All right. Let's get splitting. I'm going to start using red for my factors. 14, I can split that into 2 times 7. Okay, well we know, we've done it a lot of times, we know that 2 is prime. And if I check, 7 is also prime. So we're done with that 14. Do we need to split this n? No, it's just that n. So our prime factorization for 14n ended up being, why does it keep throwing it? Ended up being 2 times 7 times n. Now let's check the other side. It might be a little longer over there. So we're going to start, though, splitting our 42. It's even, so it's 2 times something, which is 21. All right, 21 is not even, but I know that 21 divides by 3, so it's 3 times 7. Okay, and now 2 is prime, 3 is prime, and 7 is prime. Bing, bang, boom. So our number prime factors are 2 times 3 times 7. And this n, it's just a plain n, so it's just comes down to be one factor. Okay, so this side, our prime factors are 2, 3, 7, n. Now again, we just check what matches. Okay, we have 2 and 2. We have 7 and, whoops, that's the table, and 7. We have n and n. That one doesn't look like an n, but it is an n. So the pieces that matched were 2 times 7 times n. 2 times 7 is 14 n with that n. So there's our GCF. Okay, that is the greatest common factor. Now, again, it was the same as what we started with. I promise that doesn't always happen, but it can happen. All right, one more example of this, and we'll move on to the next topic. Okay, one more time, we're going to find the greatest common factors. And our this is number 5 on the same page, so if you want to follow along. Our two pieces are, our two monomials are 5ab and 6b squared. 6b squared. Okay. Let's factor them out. If I can find my red pen. There it is. Okay. 5. What are the factors of 5? It's already prime. So this 5 is a prime. So it's done. A. Can I split a plane A? Nope. So that's 5 times A. Can I split B? Nope. No factors there. So this one already was finished. It's just 5AB. Nice. Okay. Let's check the other side. 6. Can I split a 6? Yep. It's even, so it's going to be 2 times 3. Then we're done. 2 and 3 are prime. B. Can I split a B squared? 1B, a plain B, I can't split that. B squared, I can split that into B times B. That's what B squared means. So here we go. We have 5AB for one of our prime factorizations and 2 times 3 times B for the other one. All right, let's check what matches. 5. No 5 over here. You can't add those numbers together. A. No A over here. B. There's a B over there. So B and B. So the only thing that matched in this one, the only common factor was B. So the greatest common factor, the answer is just B. So it's different from our starting numbers. It doesn't even share an A. It doesn't have any numbers. This is the only thing that they shared, their only common factor. Well, their greatest common factor. Might be their only one too. All right. So now that we know how to find greatest common factor, we're going to use that to find the least common multiple. Okay? So first thing you got to do is jump. First thing you got to do is factor. That's to get your greatest common factor. Then you're going to be able to find your least common multiple. All right. So let's start out with an example. The least common multiple, we have to start by finding GCF. So this is number 7 on your practice problems. Why do I keep getting short? Okay, number 7. 20C. And the other piece is 12C. Okay, so first we have to do our GCF. Okay, so the GCF is first. GCF. So factor out this 20. I can split that into 2 times 2 times 5. Okay. I split it into 2 times 10, then 10 is 2 times 5. So it's 2 times 2 times 5. This C, no factors, so it stays together. So there's our one factorization. 12C, let's check it. I can split 12 into 2 times 2 times 3. 2 times 3 is 4. 4 times 3 is 12 again. And those are all prime. And the C can't factor, but it can't escape. So there we are. Okay. Now we check what do they share. A 2 and a 2. A 2 and a 2 again. A 5? No. A C? Yes. All right. Now we've got our GCF, but we don't want to find our GCF. We want to find our least common multiple. What that means is we take all of our factors and put them down on a new line. But we only use the circled ones one time. So 2 comes down. We're not going to use that one and that one anymore. Those are the pair. We only use one of them. Next one is 2. Okay, that one and that one are done. Okay, we've got a 5. He comes down 2. We've got a C. We only bring down one of the C's. For every pair, only the one comes down. When we matched them, we only use one of the matches. And for each match, 3. Okay. This is the answer. Let's just clean it up. Multiply all the numbers. 2 times 2 is 4. So 2 times 2 is 4. The 5 and the 3 are still here. 4 times 5 is 20. The 3 is still here. 20 times 3 is 60. And C. This is the least common multiple. That means this is the number that both of these can multiply into. If I multiply this by 3, I get 60C. Oh, look at that, the 3. If I multiply this one by 5, I get 60C. Oh, look over here on this side. It's a 5. Interesting. I don't need that. That's how we find the least common multiple. Factor both pieces. Then we find our matches. Then we write all our factors over using only one of each match. Right? We had a matched 2 and 2. One of them came here. A matched 2 and 2. We only used one of them. 5 came down. C. We had matching C's, so only one C came down. And then we had a 3. Okay? All right, we're going to try another one. Giving you lots of examples this time. Because it just takes some time to get used to working with these. All right, number 9 on the same page. We have 36AB, and we have 4B. All right, let's factor. Factors in red. I can split 36 into 6 times 6. Those are not prime, so I need to split them into 2 times 3 times 2 times 3. 6 splits into a 2 and a 3. Wow. Eraser. 3. All right. That's the 36. A doesn't split. B, no factors. So there we are. The prime factors of 36AB. Sometimes you might want to write it in order, so it's 2, 2, 3, 3AB. It's the same, it's up to you. In a finished answer, you want to put them in order. 4, I can factor that into 2 times 2, and the B cannot factor, so it is just a B. All right, that one was a lot easier. Time to match. So this is the GCF line, right? We're looking for the GCF, but we're not going to use it. We just want to match them. A 2 and a 2 matched up. A 3, no match. A 2, yeah, there's another 2 over here, so we can match them. 3, is there a match? No. A, no match. B, yes, there's a match. All right, let's write them all down. Factors, start with our factors. A 2, if we use this 2, this one's already done then. We don't want to use both pieces of the match. 3 times 2, so that pair is done, times 3 times A times B, and that B means that that pair is done. So we don't use these extra matched pairs, but we do. You might be thinking, oh look, a 3 and a 3, why didn't we match them? We only match between the groups. So this group has to match that group to get circled. Otherwise, they are not common factors. They're just factors of the same number, right? These are all from 36. We need to see if they match the 4B, but they didn't this time. Okay, now we just put it back together. 2 times 3 is 6, times 2 is 12, times 3 is 36, AB. Oh, interesting. So sometimes your least common multiple can be the bigger number, right? That means we can multiply 4B by 3, 3, and A to get 36AB. 4 times 3 is 12, times another 3 is 36, times A and the B. So this time, one of the numbers was already the least common multiple. It's just interesting. It doesn't matter too much right now, but it's interesting to know that that works. All right, last example. Then I'll turn you loose. Number 11. Seven x and 12x. Okay, let's factor. Can I split 7? No, 7 is already prime. Can I split x? No, x is already finished factoring because it's not x squared or x to the 4th. All right, well, that's nice and easy. 12, I know I can split that into 2 times 2 times 3. It's good to memorize some of the smaller numbers prime factors, right? Every time I see 12, I don't have to sit there and think 2 times 6, and then 6 is 2 times 3, so it's 2, 2, and 3. I just memorized it. And the x, which is already factored. Finished. Okay, that's our GCF line, so now we want to match the pairs. 7, no matches. X, yeah, there's a match. That means that this 2, and this 3, they don't match anything over here. So they don't have any common factors. So we take all of our factors now. Now we're going down to the LCM line. This is what we want to do with LCM. We want to take all of our factors. 7, x, but this x is matched. This x is paired. So that's done, and that's done. Then we keep going. 2, another 2, and another 3. Oh, just a 3. Okay. Clean it up. 7 times 2 is 14. Times 2 is 28. 28 times 3 is 96. And then the x. That is the least common multiple. That means 7x times 2, 2, and 3 will become 96x. Nice. 12x times 7 will also be 96x. It's very neat how they match up like that. That's the definition of a least common multiple, though. The two numbers will multiply into that number. Very neat. All right, we're all set. So I did 6 examples from your packet, from your assignment. So if you want to try those first, then come check my solutions. That might help you understand for the other problems. And if you get stuck, always come to office hours on Teams.